Hey everyone, this is Mr. Schultz here, and we're going to take a look at 10-4-1, second to the last section that we have of the year here. So 10-4-1, what is the best method? So we've learned a bunch of methods for solving systems. We've learned elimination, substitution, equal values, and so now we're just going to choose, work on when do we choose each thing. So when you have a system of equations solved, how do you know which is the best method to use? Today you'll focus on how to choose a strategy that is most convenient and efficient for solving the system. So big thing there is that efficient piece. Any method will work for any of them, but some of them will just be more difficult. So we'd like to take a simpler route where possible and be more efficient. So let's take a look at this. All right, so first question number 108 says that Erica works in a soda bottling factory. As bottles pass her on a conveyor belt, she puts caps on them. Unfortunately, Erica sometimes breaks a bottle before she can cap it. She gets paid 4 cents for each bottle she successfully caps, and her boss deducts 2 cents from her pay for each bottle that she breaks. Erica is having a bad morning. 15 bottles have come her way, but she is breaking some and has only earned 6 cents so far today. How many bottles has Erica capped and how many has she broken? So our first step here is we want to write the system, so basically just 2 equations, so that we can go and then choose a method and say which 2 make sense. So you could use substitution, elimination, equal values method, all that type of stuff. So let's first write the system here. So taking a look at this, when you're writing the system, if you find this to be a challenging thing, this is something that I just really encourage you to keep working at. It's not something that necessarily comes super easily, but sometimes it just happens and you just start to see patterns here. So let's just take a look at our key information. I like to highlight that stuff just so that I know what I'm focusing on. So here, she gets paid 4 cents for each bottle she successfully caps, and her boss deducts 2 cents from her pay each time she breaks one of them. So deducts is a key thing, so she's losing 2 cents, but she's gaining 4 cents for each one that she caps. And then it says she's having a bad morning. She's got 15 bottles, and she's only earned 6 cents. So big things that I look for here is what's our kind of totals? Well, in total, she's earned 6 cents. So I'm going to set that equal to 6 cents. But I know that 6 cents is based on 4 cents for successfully capped, but losing 2 cents for each that she has not capped, or that she has broken. So minus 2 cents for each one that she's broken, 4 cents for everyone that she successfully caps or that she's capped. So there's my first equation. She gets 6 cents, which is based on if she successfully caps 5 of them, well, 5 times by 4 cents, she'd get 20 cents. And then if she broke one, then you'd minus 1 times 2, which is 2 cents. So a good way to check out your equations is just choose a couple of numbers and plug them in and see if it makes sense how much money she has earned yet. Okay, then we need one more equation because we're looking for a system. So we need at least more than one. So far I've used this information, and I've used this information, and I've used this information. So my last piece, just if 15 have come her way, well, 15 bottles, that's just going to be based on the number that she capped plus the number that she broke. So there is our system, and that's it there. So now our second step here is to solve this system using 2 different methods, substitution and elimination. So let's start off with the elimination because that's kind of our freshest approach here, and I'm going to take a second and set this up. So in elimination, we want to try to get things lined up, so my S's, my B's, and then the numbers all lined up there so that we are ready to go through and solve this here. And we do that just by making a big plus sign. But right now, if I add these things up, I'm not going to eliminate any of my variables. The whole point of doing this is to try to eliminate one of the variables. But I do notice that I have opposites in my B variable here. So I've got a negative and I've got a positive. So what that shows to me is that if I were to multiply this whole thing by 2, well, then I'd have 2 of my B variable and negative 2 of my B variable, which would then end up being the same thing. So what I'm going to do is I'm just going to multiply this whole thing by 2, and then I can go through and add it. So this blue expression, I'm going to multiply the whole thing by 2 and turn it into 30. Multiply the S by 2, that makes 2S. Multiply the B variable by 2, I've got a positive 2B. Now I can go through and I can add up these 2 pieces here, the pink and my new blue, and see what happens. So I've got 36. I've got 6S, and then exactly what is supposed to happen, positive and negative, will cancel, and I'm just left with that. So now this is a pretty straightforward one to solve. Divide by 6. You get that S, so she successfully capped 6 bottles. So now I just need to find out how many has she broken. So I do that just by plugging into my original equation. So 15 bottles in total have come her way. She's capped successfully 6 of them. So then how many has she broken? Well, that tells you that she has broken 9 of them, hence the bad morning there. And then we can check this by seeing, does it work? If I take 6 that she successfully capped, 6 times by 4 is equal to 24. So she made 24 cents on those 6 successfully capped. Then she loses 2 cents on the 9 that she has broken. So 2 times by 9 would be 18. So 24 minus 18 is equal to 6 cents. Yes, this does work. I am good to go. Now it does say to do it in 2 methods here, so let's try doing this using substitution. So I'm going to set that up right over here. Okay, so in my substitution method here now, I like to look for things that I can easily solve for one of the variables. So this second equation doesn't really jump out to me because we're going to have to do some sort of division piece there. I could do it, but I just don't want to really deal with that. So I'm going to jump to my first one because I've just got these 2 variables by themselves. It doesn't matter which one you want to solve for first. Let's solve for S. So I'm just going to subtract B on the other side. I'd have 15 minus B is equal to S. Now I'm set to plug that in for my substitution. So I'm going to take 15 minus B. That's what the successful cap is. So I'm just going to plug that in for S right there and go ahead and solve this. So I've got 6 times by 4. I've got 4 of the S though. My S is 15 minus B. And then I'm going to finish off by just saying subtract B. A good check here to make sure that you've done it right. I'm down to 1 variable. I've got B here and I've got a B variable here, and that's it. So I've got the same variable. I've just got one. I have got down to just one of my variables, and I'm just going to go through and solve this. And I'm going to do this fairly quick, so if you want to slow down the video, you sure can. But I'm going to do this quick because I think that by this point we're hopefully pretty solid at solving equations and don't need to be kind of handheld through this process here. So I'm taking off 60, got negative 54 is equal to negative 6b. So my final step is divide by negative 6. So b will be equal to 9, which is good because that's what I got last time. So then same thing as last time, I'm just going to take this value and plug it back into my original equation right there. So I'm going to have 15 is equal to the number of successes plus the number of breaks, which we just found out was 9. Solve for S. Found out that S is equal to 6. These 2 solutions agree, which is good because both of these methods should be showing you the same answer. They're just different methods to get there. So as you can see, they both kind of take a little bit of extra work. I'd probably go with the substitution route just because to subtract off a single variable is a little bit easier to me than trying to find something to eliminate here. But it doesn't matter. If this elimination makes more sense, lean into that. If the substitution makes more sense, lean into that. Let's take a look at our next problem here. So our next problem says this: for each of the systems below, decide which algebraic solving strategy to use. So basically we're going to decide which is the most efficient and convenient of substitution or elimination, or of course could you set them equal to each other and use equal values method. So we can either do substitution, elimination, or equal values. So take a second to look at these and decide what you think here, and we'll go through them in just a second. Okay, so my first one, A, I've got a variable by itself here, and then I don't have a second thing equal to it. So usually when I'm looking for equal values, I'm looking for something where I've got both of them equal to the same value. So this one, and it's not lined up for elimination, so this one I would go to substitution, because I could easily take this and substitute that in right there, and I should be good to go. On B, I think I would go with elimination method here. And the reason why I'd go with elimination is because things are all lined up. I've got my x's lined up, I've got my y's, and I've got my numbers all lined up there. So the only thing I have to do is just do a little bit of subtraction here. And I could just subtract these 2 things. I'd be left with my negative x, my y's will cancel, and I'd be left with a negative 1. So really quick and easy to do that. We're actually not going to solve each of these here, but I'm just kind of showing you the idea. Let's take a look at the next one. So I've got two variables equal to each other, so this one just jumps out to me as doing equal values method. Because I can set this equal to this because they're both equal to x. If you wanted to do this as substitution, it's kind of the exact same thing as equal values because you're substituting in 3y minus 2 in for x here. So it's kind of the same thing, but we're just going to call it that name because that's what we have been calling it in the past. This one here, this one here also jumps out to me as substitution because I have my x that is equal to stuff here, so I'm just going to shorthand that to be sub. It's in substitution. My next one also I think would be a good substitution one because I've just got the single variable that's equal to that stuff. And then this next one, F, there's just not really a super great option here because anything that you do, you're going to have to work at it a little bit. If you do substitution, minus 3x, and then multiply by a negative 1. If you do elimination, you're going to have to do some sort of multiplication here for that. If you're going to do equal values, then you're going to have to do a lot. So I'd say this is either going to be elimination or substitution. But if I had my pick, I'd probably go with the elimination method because I do have opposites here in my y's and everything else is lined up. So I just have to multiply this one by 2, and then I've got opposites, and I can go from there. Next one, G. This one, again, jumps out to me as being elimination. Again, because I've got things kind of lined up. I've got these opposites happening, and I can see this 3 and this 9 are going to be a little bit friendly here. That I just have to make this be 3 times as big so that my 3 and my 9 will cancel there. Oops, elimination with an N. And my very last one here, this one to me is a substitution because we have y is equal to this stuff, so I just need to plug in this stuff for y right down here. So this stuff right there for y, then go ahead and solve it. So basic things that you see here in patterns is just if I've got both of them set up, I'm going to go with equal values. If I've got one of the variables set up, I'm going to go with substitution. If things are lined up, I'm going to go with elimination. And then sometimes there's nothing that's really kind of set up and great that you have to do some sort of something to it. That's when elimination makes sense. And sometimes you even have some beyond that that just none of them are really quick and easy, so you just kind of have to go for it. So let's take a look at the next question. Okay, so the final question here says, with your team, use the best strategy to solve each system now and go through and do that. So I'm not going to walk through each of these steps, but I'm just going to basically kind of show you the steps on screen here. So if you want to pause and try it, go ahead and do that, and then I will show you the solutions with the work in here in just a second. All right, so here are your first two solutions, just substituting in right over here, this right into there. Distribute, go through and solve. We get y is equal to 1, plug the y back in, solve for x. Same thing here, except I'm just going to subtract to create opposites in the y's. Gets me down to that negative x, so then divide by the negative 1, so that x is equal to 1. Plug it back in, y is equal to negative 2. So 2, 1 is for A, and 1, negative 2 is for B. Let's take a look at the next one. Same type of situation here. You can take a look at and pause the video now, and I will show you the solutions here with the work in just a second. Okay, so on our next one here, we used equal values method, so I just set these two things equal to each other. Went through and solved, got 1/2, used that 1/2, plugged it back in, got negative 1/2. Correct answer is negative 1/2, 1/2. On the next one, we're going to use elimination, or excuse me, substitution. So I'm just substituting this in, and notice here I've got 4y and minus 4y. That makes 0y. So all I'm left with is 12 is equal to 10. Well, 12 is not equal to 10. That is not true. If you get something like this, that means that there's no solution. There's no number that's going to make these two things cross. And what this really means is that you're talking about parallel lines. So if you were to put both of these into slope-intercept form, you would find out that they both have the same slope. And therefore, they're parallel lines. They're never going to cross. There is no solution when they cross. Let's see the next couple. So again, got a few seconds here, then I'll show you the worked out algebra along with the solutions. All right, so on this next one here, we're going to do substitution again. And this one's kind of weird because you've got this double distributive thing here. So you've got 2 groups of 7 plus W. So if you wanted to distribute that at the front end and call it 14 plus 2W, that might make your life easier because you're going to have to double distribute here by plugging this stuff in for D. So you can see I've kind of got 2 sets of parentheses here. So I first distribute that one, then I distribute the second one, and you've got to distribute here. So lots of distributing happening here, but pretty much the same thing from there. The W is equal to 3, D is equal to 20, there is your answer. Now, on this one, if you notice when you're doing elimination, you multiply by 2, then when you add these up, you get this 0 is equal to 0, because everything cancels. This is just the opposite of this line. If I just were to multiply by a -1, I'd get this line. If I were to multiply this one by a -1, I get this line. When you've got all real numbers, what that really means is that these are the same line. If you were to put these into y equals mx plus b form, you'd get the same equation on both of them. So it's the same line, meaning that every single number is going to work because it's the same. So let's take a look at our last set of 2 here. Okay, so same thing. Take a few seconds and pause the video and check these out, and then we'll go through them. All right, and here's our last set. So just going through and multiplying this one by 3 to be able to create those opposites of +9 and -9, and then going from there. So I'm just going to add them up. I'm left with 17x and a 0. Makes it 0. Plug that back in, get -2, 0, -2. And then on the last one here, letter H, similar type of thing, but doing substitution. So I'm going to plug that in for my y. And key part here is make sure this is saying to subtract y. Well, so that means subtract all of this stuff. So it's kind of like distributing it. So I'm going to distribute the negative to the x. I'm going to distribute the negative to the -3. So subtracting a -3 is a +3. Subtracting a positive x is subtracting x. Combine like terms, find out that x is 10, y is 7. Correct answer is 10, 7. And that's it. That's the big thing, is just basically going through and being able to choose which method makes the most sense, which one's going to make your life easier. And that's it. Have a good rest of your day.